Hello everyone and welcome to the topic of high mobility enhancements. In this we are going to discuss about in release 18 high mobility enhancements and what is there in high mobility enhancement. High mobility enhancements include exploiting the channel time correlation. So how we can exploit this channel time correlation? How we can have via CSI extrapolation. That means with the help of channel state information extrapolation, we can exploit the channel time correlation. How? The UE reports, like UE can report a bundle of multiple CSI reports. So this report so that it can capture the Doppler information. After capturing this Doppler information, the G node B extrapolates the CSI for the PDSCH transmission. It has specification impact that the bundled CSI-RS transmission, channel state information reference signal transmission, like sufficient time domain density for the Doppler estimation should be there. And bundled CSI reporting, that means there should be efficient time domain CSI compression. Next is Doppler aware CSI type selection. For a given UE mobility, some CSI type is always preferred. Like low mobility has type 2 CSI which is preferred, medium mobility has bundled CSI which is preferred, and high mobility which has type 1 CSI or semi-open loop CSI which is preferred. The proposal of this that the network configures multiple CSI types in one report configuration. The UE can provide the CSI type recommendations. Next is UE initiated CSI feedback. UE can initiate CSI feedback. Now, what is the issue? In release 15 or release 16, a CSI is per the network request. Here in that case, network will trigger new CSI upon identifying the outdated based on hybrid automatic repeat request acknowledgement procedure. So this procedure consumes the latency. Why it consumes latency? Because of the failed PDSCH and updated CSI, which causes inefficient rate control in high Doppler scenario. High Doppler scenario like ultra reliable low latency communication. To remove that, we have UE initiated CSI feedback. UE initiated CSI feedback so that we can enable more efficient rate adaptation. It has triggering mechanism, measurement, CSI measurement resource. We can reserve uplink channel to carry the CSI and processing criteria like CPU, reference resource, timeline, priority rules, etc. Now next is uplink TPMI enhancements. Now TPMI. Now this is high resolution TPMI. Or sub-band TPMI. Now here there is a motivation for this. Now what is the motivation? That current NCB based uplink, it can exploit this SVD of the channel because it relies on the full reciprocity. TPMI, which is transmitted precoding matrix indicator. This is an indicator which is transmitted precoding matrix indicator. So we can use high resolution or subband TPMI. So current band based uplink is worse than the NCV based uplink because of the low resolution quantization of the SVD precoder. So for that we can use TPMI or we can have enhancement in this. SVD as singular value decomposition. So wideband or subband high resolution precoding versus release 15, they can provide significant gain compared to the release 15. So it is better performance compared to wideband NCV. We can see here L1 L2 based intermobility. Serving cell PCA 1, 2, 3 PCA L1 L2 mobility range within serving cell PCA 1. There for PCA 1 we have a mobility PCA 2 and PCA 3, and this is mobility outside, which is layer 3 based mobility. These are layer 1 layer 2 based mobility. UV travels from P to Q at different speeds plus 3 dB handover hysteresis. If we calculate, these are the cells. Simultaneous uplink. This is across multiple channels or within one channel. Now what happens in this, that release 16 they allows for simultaneous downlink transmission. That means two PDSCH associated with different chords at pool index. One PDSCH with two TCI states in the SDM or FDM manner. Release 17 PUSCH or PUCCH only focuses on TDM case. This is TRP1 to UE and PDCCH, how they are transmitted. So for the proposal of this, that it can simultaneously support PUSCH in one component carrier. So core set pool index framework, this is basically a natural starting point. Uplink control information multiplexing rules for simultaneous PUSCH and PUCCH. And it has a headroom impact. It can support multi-beam PUSCH in FDM SDM manner, and this is based on release 17 TDM enhancement. Also uplink only MTRP operation. There is a asymmetric downlink uplink densification, and it can enable new MTRP deployment models. There is a densification of uplink only modes which are connected to G node V with the help of the backhaul, and reception only capability of additional nodes, cheaper deployment. Because of this, uplink coverage and capacity should be improved. The proposal of this is that there is an enhancement on uplink beam management, that means SRS based on connected mode, and initial access for capacity improvement. And there is uplink power control enhancement, PL compensation with respect to PLRS measurement. Link efficiency improvement also for physical uplink control channel. DMRS based coherent communication perform worse than less non-coherent transmission because of DMRS overhead, bad channel quality, channel estimation quality, and existing PUCCH channel code. Thank you.